Today we're going to talk about slope, but first I want to talk about slope where we use it outside of the math classroom. So here I have two pictures. I have a picture of a house, and right now the arrow is showing the slope of the roof. And let's see, the slope is how steep something is. In the second picture we have the slope of a hill. So we have the steepness here and the steepness here. Which one do you think has more slope? Yeah, well, we can look, if I was going to try and walk up this roof, it would be much more difficult because it's more steep. However, if I'm trying to walk up this hill, it still is fairly steep, but it's not as steep as the roof. So this line here has more slope. But in mathematics, we like to be a little bit more specific, and we like to describe the slope or the steepness in numbers. So let's check out how to do that first. Talk about slope in mathematics. We always use the letter M. And so our formula for the slope is slope equals the rise over the run. So let's take a look and see what that means first. Here I have a picture of a line, and I want to find the slope of that line. So first I'm going to draw my x-axis. So our x-axis always goes this way. And then our y-axis. Okay, so to find the slope of this line, we have to find 2 points. I'm going to label this point here A, and this point here B. Okay, so to get from this point to this point, we would have to run this far and then rise this much. So to find the slope of this line, we could say we have to run over 1, 2, 3, 4, 5. And we would have to move up 1, 2, 3. So our rise then is 3. And we run over 5. So the slope of this line here is 3/5. And if we wanted to, we could change this to a decimal and also report the slope either as a decimal or as a fraction. So let's try our first example. We have a ski hill here, and we want to find the slope of the hill. So we have this part here labeled as 45. So we chose this point here, and we chose this point here. And so which part, the 45 or the 15, is our rise? Yeah, we're rising up. That's always our vertical distance here. So the 15 is our rise. And then that would mean this is our run, 45. The run is always horizontal, and the rise is always vertical. So we run over 45, and we rise up 15. So let's write our formula. Okay, so we have M equals rise over run. So our rise was 15 meters. And we ran over 45 meters. Alright, let's simplify this a bit here. So both the top and bottom can be divided by 5. Alright, so 15 divided by 5 is 3. And 45 divided by 5 is 9. We have 3 9s. So that can be simplified even further. What can we divide into the top and the bottom? Yeah, 3. So let's divide by 3 again. Okay, so 3 divided divided by 3 is 1. I'm just going to move this over here. And 9 divided by 3 is 3. So the slope of this line is 1/3 or 0.33. Your turn to try. So I'd like you to press pause on the video now and try to find the slope of this ramp. So press pause and then try on your own. Now let's try it together and see if your answer is correct. So let's begin by writing the slope formula. We have m equals the rise over the run. If you have trouble remembering if it's rise over run or run over rise, you can think of the first thing you do in the morning is you rise out of bed, right? So it's always rise over run. Yeah, and then you run late to school, right? So anyway, so rise over run. Which part is the rise? Is that the 5 meters here or the 1? Right. Well, 1 is going vertical, so that's our rise. And here, if we chose this point here, and we went here, to get from A to B, we would have to run over this much, right? So that would be 5. All right. So our slope then is 1/5. So the slope of this ramp is 1/5, or if we converted this to a decimal, it'd be 0.2 meters. Special case, we use slope a lot in physics or when we're looking at graphs. So when we have a distance-time graph, and a distance-time graph just means that we measure the change in distance here over time. So our y-axis is distance and our x-axis is time. So if we were to find the slope of a distance-time graph, that gives us speed. And one way to remember that is if we put our units of measure into this formula, we'll actually get the units for speed. So the rise, that's our y-axis here, right, up and down, vertical, is measured in meters. And the run, the horizontal here, is measured in time, in seconds. Okay, so if we were to find the slope of this line, what we're actually getting is meters per second, so speed. So if we look at these 3 lines here, we have, I'm going to label them, A, B, and C is this straight line here. Which one would have a greater speed? So greater speed or greater slope? Yeah, A is more steep, right? So this one would be going faster. That means then B, because it is more shallow or less steep, is going slower compared to A. What do you think is happening to C? Because we actually haven't looked at the slope of the flat line here. Well, let's take a look at it here. Let's break it down second by second. At the beginning, this person is 15 meters away from wherever 0 was measured. And then 1 second later, he's still 15 meters. 2 seconds later, he's still 15 meters, 3, so on. All of that time, all of that 6 seconds, he's still at 15 meters. So he's not moving, so that will give us a flat line. So if we're looking at a distance time graph and we have a flat line here, this means the person's not moving at all. Okay, or we could say they've stopped, or they're at rest. So just to recap, the more steep a line is, the faster it's moving. A line that's less steep is moving more slowly, and a horizontal flat line like this means that they're not moving at all. Let's try another example. So in this question, we have a distance time graph. This time our distance is measured in kilometers, not meters, and our time is measured in hours. So it asks us, determine the slope of Angela's distance time graph. First, before we start, what is the slope of a distance time graph measuring? Yeah, it's measuring the speed. So we're actually trying to find Angela's speed. Okay, so first thing we do, find 2 points. So I'm going to pick this point here, and another nice point. This one here. Okay. So this point is, the x is 1, and our y is 50. And this point here, the x is 5, and the y is 300. Okay, so let's write our slope formula. Rise over run. So to get from this point to this point here, how much do we have to rise? Yeah, we'd have to go from 50 to 300, so the difference, 50 minus 300, and then we would have to move 1 to 5. Okay, so let's find the difference there. So 300 minus 50 is 250, and 5 minus 1 is 4. All right, let's simplify this. What I'm going to do is divide each by 2. Okay, so divide this one by 2 and divide this one by 2. I know 4 can be divided by 2, and anything with a 0 can easily be divided by 2 as well. So 250 divided by 2 is 125, and 4 divided by 2 is 2. Okay, so let's divide it by 2 one more time. So 62.5, and we were measuring kilometers per hour. Okay, so Angela's speed is 625 kilometers per hour.